We would like to prove the following inequality. So that the integral from 0 to 1 of sine x over e to the power of x plus 1 is bounded between these two values, this one and this one. How do we do the proof? Sine x is oscillating between -1 and 1. Now we divide by e to the power of x plus 1. Of course, e to the power of x plus 1 is always different from 0. And we pass the integral from 0 to 1. Let's call this integral I. We can explicitly calculate this integral. We can add and subtract e to the power of x. And then we can split the fraction. So I have the integral from 0 to 1, e to the power of x plus 1 over e to the power of x plus 1 dx, minus the integral from 0 to 1, e to the power of x over e to the power of x plus 1 dx. I can simplify this fraction, is just dx minus the integral from 0 to 1 e to the power of x over e to the power of x plus 1 dx. This can be written in the following way: from the integral from 0 to 1 x prime dx minus the integral from 0 to 1. I write the derivative in the numerator like this, and then in the denominator I write the denominator. This is just x using the fundamental theorem of calculus evaluated at the boundary values minus the natural logarithm of e to the power of x plus 1, 0, 1. So this is 1 minus 0 minus natural logarithm of e to the power of 1 plus 1 minus natural logarithm e to the power of 0 plus 1. This gives me 1 minus the natural logarithm of e plus 1 minus the natural logarithm of 2. This is 1 minus the natural logarithm of e plus 1 over 2. This can be written as the natural logarithm of e, which gives me 1, minus the natural logarithm of e plus 1 over 2. So what I get is natural logarithm of 2e over e plus 1. So I have minus the natural logarithm of 2e over e plus 1. I have the integral from 0 to 1 sine x over e to the power of x plus 1. And the upper bound is the natural logarithm of 2e over e plus 1. I can chew up the minus using the properties of logarithm, and this can be reversed, e plus 1 over 2e. And finally I obtain the desired inequality. So it's the natural logarithm of e plus 1 over 2e. And this is the argument of the logarithm is flipped. Let me rewrite it more clearly. So this is my final result, and this concludes my proof. So the key steps is that I have the sine function oscillating between -1 and 1, divide by e to the power of x plus 1, integrate from 0 to 1, and I can compute these integrals at the two upper bounds of the upper and lower bound of the inequality, and obtain this final inequality. Why do I do this procedure? Because computing this integral is not an easy thing. You can use, yes, you can compute it explicitly, some integrals, but some integrals it's not possible to do that. So what you do is you estimate what would be the value of the integral. So in this case, the value of the integral is between this lower value, natural logarithm of e plus 1 over 2e, and between the other value, natural logarithm of 2e over e plus 1.